Hi everyone, my name's Tom Hoeineke. I am a software developer. I have 4 years of professional experience as a full stack developer in the .NET stack, but as a hobby and otherwise, I enjoy learning C and have learned some C, and that's what this project is about. I also have some interest in C++, Node, and some other languages. I'll walk you through this project really fast. So this is Where's Waldo? And the main point of this project was to teach myself about C and memory just because I've always had an interest in it and never really went deep into it. The Where's Waldo theme is because in this project there are two asymmetric directory trees built out. One is built out breadth first, the other is built out depth first, and they're both randomly built out. And within those two random trees, you'll get a random number of text files that are filled with lorem ipsum text. The first go around in the program is creating the trees with the text, and when each text file is made, the string Waldo is randomly injected after each word. I think it's a 1 in 50 chance or so, something like that. So there's about a 50-50 chance that the word Waldo will show up in each text file. The way I have it set up, the tree will go up to 4 levels deep and will be at least 2 levels deep. In the top level, there are 2 log files. One log file tracks the creation order when each asymmetric tree is made, and the other log file goes through a second round, same order as the tree was created in either depth first or breadth first, depending on which tree it is, and marks in what order it finds all the Waldo strings and logs what file path and what line inside that text file it found the Waldo instance. So I'm going to walk you through really quick and show you kind of how it works. So for my code here is on GitHub, and it's under the name Tom Hoeineke, my name, Where's Waldo 2.0. This is the latest version, which has the most comments and is the most refactored and clean, but unfortunately, I've spent so much time on this as a hobby. This isn't the best working version. I will show you the best working version, but this is the cleanest to look at as far as just looking through the code to see how it works. I will just walk you through main really quick, which is kind of gets the gist of it. So I tried to comment this out pretty well and pretty clean for a C# developer at least. You can see all my global variables for all the paths and things I have to build out. So we're going to create our level 1 directories with the text filler file, which is just a lorem ipsum file that a file stream uses to fill the text files, and our log files, which are creation and citing files. You can see here the creation logs are being made, the citing logs for each tree. One is breadth first, the other is depth first. And then if we go on, we can see the rules right here. So random asymmetrical child directory tree, random between 2 and 4 levels of depth, random 1 to 3 child directories created within each directory. So any parent has a chance of 1 to 3 children being made, and inside each folder 1 to 3 text files can be made, and they're numbered in like 2-1, 2-2, 2-3. So directory 2-1 could have children of 3-1, 3-2, 3-3. 2 could have children of 3-1, 3-2, 3-3, and so on. It'll be much easier once I show you the actual program creating these files and filling them out on my desktop. So after it creates all these, the actual trees, we'll see right here, you create the breadth tree, you create the depth tree. And so once those are created, it's going to go through a second time because the program isn't supposed to kind of know how they were created. It's just a random tree that it's given. It uses some recursive algorithms to go through either depth first or breadth first and find all these Waldo instances. So we can see the sightings log files for each one are created here, and we can see this is where we go through and we log everything. So now I'm gonna actually build out the code once to show you it actually exists and is working. And this also gave me a chance to use Xcode, which I liked using a different IDE just to kind of see what the difference is, because I mostly used Visual Studio as a developer. Let's see. So I just ran this, which means it has created the files to my desktop, which I have told it to use a Waldo output-2 folder. So when I go out to the Waldo-2 folder, you're going to see that my two trees were made. So here we go. So here we go. So now you can see, got this big nice folder. And you can see in here, this is just lorem ipsum. I think it's about 50 or 60 words or so. So this is the palette, this is the open canvas that's in each text file before Waldo is inserted randomly once after each 50 words right after the file is made. So we'll see in our breadth first that we have these two log files. Same thing if we go to the depth first. We also have two log files, the creation and the sightings. So I'm going to try to go over this simply so you can kind of see the rules. So you can see that we randomly got 3 directories for level 2. We may have only had as little as 1, but we got 3. So if we look in any of these folders, we can see, oh, we randomly got 3 for this one. So this one has a lot. And if we go here to the next level, we only got 1. So let's check out this other level 2, 3. It only got 1. Let's see how many 4s it got. It only got 1. So you can kind of see the pattern. There could have been, a maximum of 3 children for every single parent folder. So we can just click in one of these, and you can see there's 3 text files here, but there's only 1 up under 3.2. So that's also random. So everything's randomized, the amount of child folders and the amount of text files. Once it got this big to 4 levels, and I was putting 3 files per, up to 3 files per folder, it just became so many files, and if I even had a small memory leak, a lot was going on. So let's just open one of these files, and we can see, just lorem ipsum. Looking over there really quick, I can't really see a Waldo in there. Maybe there is, maybe there isn't. So the beauty of it though is, so we have this random tree. Well, now we can see the breadth creation log. So if I maximize this out here, we can see that the pattern is that since it's breadth first, it's going all the way across the 2s before it goes to the 3s. So we can see 2 1 2 1 2 2 2 2 2 3 2 3 2 3. Okay, now once all the 2s are done, now it's going to go to only the level 3s, and we can see if we move over here, well, now you have 3 1 3 2 3 3 3 1 3 2 3 3, and so on. There's no 4s that are popping up because it's not depth first. This is the breadth first, so it's going horizontally across each level at a time. And of course, as the levels get deeper, there's a larger chance that you'll have more files and more folders because the trees kind of grow, at a pretty high rate. So now we'll see if you keep going down more. Now you have 4s only. So you can see that it did create it in a random order with a random number of text files and so on in a breadth first order. So now we can actually see the useful part, which is Waldo are in those files randomly. And here's a breadth first way of going down a random breadth first tree and finding in every single text file, finding Waldo. Okay, so here we go. So now this is where we can actually test it. And again, we see level 2, then all the level 3s, then all the level 4s in sequential order, breadth first. And you can of course see, which is maybe confusing at first, but this is the easiest way I could think of. You can see level 2-1, then child 3-3, then 4-4, so on. And this one is level 2-2, which comes after 2-1, 3-1. So even though 3-3 is a higher number before, you have to remember that it's based on the parent, and the numbers reset each time underneath. So if you go across, this number would be higher as it goes down if you kind of concatenated these level numbers together, and so on. So let's just pick, I don't know, let's pick line whatever 3. So hopefully I can remember this. So level 2131 file 1. Level 2131 file 1. Let's see what we got there. And level 2131 2131 file 1. 2131 file 1. And I think it said line 4. So here's 2131 line 1, 4, and then we have a Waldo. We actually have 2 Waldos in this line. So what we can do is go back and check and see if there's two instances of it coming up in a row of the same thing. And then here we go. So we're at level 3. Well, we see there's 2 instances of it popping up. Now you can go through, I could go through and check more. You can test this yourself. Just I fortunately did not put enough time into this. It just took so long already. I didn't make any sort of pop-up window or UI. You'd have to dig into the project and find the line where you'd want to put it on your desktop. Also, this was made for macOS or Linux. There were some extra things I'd have to do with C for digging into the files and streams and things like that for it to work on Windows that I did not do. So I'll show you the depth one now. So depth's the same idea. We only got 1 this time randomly. We could have had 3 level 2s. We got 1, and we only had 1 level 3, which is also randomly small, but we see we did get 3 level 4s randomly, and we got all these little files. So again, if we go to the creation log, let's see, it looks better if it's all on one line. Okay, there we go. So what it will do is it'll go deeper first and then jump back in. So you would see if there were more files, which I may actually create again during this presentation just to see. But 2131, 2131, 2131, 41, it goes deep first, but again we can't see because there's only the 3 ones. So I'm actually gonna run the program again really fast, and when the program runs, where it makes the files out on your desktop or wherever I put Waldo output 2, on my desktop, it recursively clears out every directory and file, using C on there, and clears it out before rebuilding it. So if I go back to my project and I rebuild, we'll see that I'll get a different random tree, which is also an interesting part of the program. So I just run it. Let's see. So I'm going to get out of here. I'm going to go back to Waldo output 2. So if we go back, see, now I have 2 instead of 1. And now I have all these. So now I have more to work with. Here we go. So now I have, and so I also made it so that level 2 has to have at least 1. But beyond that, it may have nothing. So at least there would be like the beginning of a tree that could randomly happen. But you can see, wow, this one has a lot. So now if we look at the directory creation log, we should see the pattern much better than before, which is you can obviously see just the pattern that it kind of juts out and goes from 2 all the way to 4, and it goes depth first, then it comes back up the tree and then over again. So you can see it juts in, out, going all the way down to the farthest leaf down before coming back up. And so on. So that's pretty cool. And then if we go to the sightings log, we can test it as well and just test a random one. Much less, Waldo did not get injected that many times for how many files. So we could just check this one, 16 randomly. So level 1, 2, 2, file 2. So 22 file 2 line 5, 22 file 2 line 5. Let's see, 22 file 2 line 5, and we have ourselves a Waldo. And I've spot checked this, and it seems very, very solid. I don't think I've found one error as far as finding anything that's off in the log files, either creation or for finding Waldo. So I just thought it was a cool program because it had to deal with file streaming, creation, deletion, recursion, string finding, creating log files, adding to log files, text filling, a bunch of memory. Having to manage memory in C and do all this was a lot to work with, but it was a very rewarding project, and I think I learned a lot. Another thing I wanted to show you guys before I end this little presentation is back on my GitHub page is that, again, I said I put a whole bunch of time into this, and the master branch right now, the latest version, does not work because I was refactoring it, and there were a whole bunch of little memory errors, and I just spent so much time on it that the half working version I just showed off. If you really want to use the working version and get it on your local machine and play around, um, go again, stay in Waldo's version 2.0, but in history, it's almost comical because the way I named it. But you could say the last tried refactor. That was my last chance when I was putting a bunch of work into it, and I just wanted to move on. But if you go back to both algorithms working with half of files completely refactored on July 25th, that will be your working version of code that I just showed you. The master version is very close. I mean, if any of you guys really love C and want to fix the main version, have at it. All right, well, that was my presentation. I hope you all liked it. Have a great day. Bye.